This video covers the idea of current. Imagine that we have a wire here, and wires are conductors, which means that the electrons easily flow from atom to atom. When the electrons are moving within the wire, they have something called thermal motion. This is the random and very fast motion that electrons have. They move in random directions, and overall the charges remain in somewhat the same place. So there really isn't any current or movement of charges going on here, just thermal motion. Now let's say that we introduce an electric field, and this is done through connecting a battery to the wire. We still have these electrons in the wire, and they feel a force against the electric field. And then the electrons still have this thermal motion, so they still have this random movement going on. But they also have something called drift speed now, which describes the electron's slow drift against the electric field. Drift speed is along the lines of times 10 to the negative fourth meters per second. And if you compare this to thermal motion, which was times 10 to the 6 meters per second, we notice that drift speed is much slower than thermal motion. So our idea of current is the organized motion of these electrons when they're flowing. And to calculate current, what you're going to do is you're going to look at a cross-section of the wire and see the amount of charges that pass through that cross-section in a given amount of time. The unit for current is an ampere, which is commonly also called an amp, and is represented with a capital A. So let's do an example. There's 10 coulombs of charge that flow through this cross-section of wire in 10 seconds. What is the current in the wire? So we have our current equation, and we can plug in our change in charge is 10 coulombs, and the time is 10 seconds, so we get a current of 1 amp. It is also important to note that whenever we talk about current in circuits, that we are actually referring to conventional current. When scientists first began to study electricity and circuits, they assumed that current was the flow of positive charges. So all of our theorems and laws were built off of the idea that current was the flow of positive charges and not negative charges. So we now understand the composition of atoms and current a little bit more and know that this idea of the flow of positive charges is simply not true. But since all of our laws and theorems were built off of this idea, we end up calling conventional current current.